Welcome to Sri Chaitanya. This is Umasankar, All India IIT Coordinator. Welcome to JEE MAX. Yeah, in JEE MAX season number 2, we are completely concentrating on a particular chapter of that complex numbers is 1, and this is about lesson number 41 of the complex numbers. And from lesson number 40 onwards, we are completely concentrating the last part of the complex numbers, which is Mobius theorem. Okay, my friends, please don't forget to check the description there. I'm providing all the links of the previous lessons, and along with that, sometimes I may give very good question papers and assignments also. And here we are completely concentrating every minute point of the complex numbers. In lesson number 40, we have discussed the nth root and De Moivre's theorem and nth roots of a complex number. Now, in lesson number 41, we are concentrating on the nth roots of unity and properties of nth roots of unity. Because exclusively the properties of nth roots of unity, you may expect a very good number of questions, even all competitive examinations. Every property is very, very important. So try to learn all these properties and by heart as a formula also. Okay, here I am giving the simultaneous explanation for each and every derivation also. Don't worry about that, but you try to understand the concept behind the screen. Now, okay. Now coming to nth roots of unity. Yes, z power, if z nth roots of unity is let z is equal to nth root 1. So this I can write it as what? 1 power 1 by n. This I can write it as, already I told, whenever to find the nth roots of a complex number, first you write or establish that complex number in polar form. So the polar form is what? R into cos theta plus I sin theta, because R is 1. Here modulus of this 1 is 1. So this I can write it as cos pi cos 0 plus I sin 0 whole power 1 by n. What I told, since my power is 1 by n, it is a rational number. So whenever a rational number is given for you, you add a general value 2k pi to the corresponding angle and multiply that with the power of power. That means what I am doing is now cos 2k pi plus 0 into 1 by n, that is pi by n, plus I sin 2k pi plus 0 into 1 by n, that is 1 by n. Simply I can write it as cos 2k pi by n plus I sin 2k pi by n. This I can also write it as e power I 2k pi by n, where k is equal to what? 0, 1, 2, 3 up to n minus 1. So if k equal to 0, that is what? Cos 0 plus I sin 0, 1. If k is equal to 1, cos 2 pi by n plus I sin 2 pi by n. If k is equal to cos 2 pi by 2 plus I sin 2 pi by 2. If I have taken all the roots, I can represent that with alpha k also. So alpha k is equal to e power I 2k pi by n, where k equal to what? 0, 1, 2, 3 up to what? N minus 1. These are all what? Nth roots of the complex number. In general, I can represent the nth roots of the complex numbers with 1 alpha, alpha square, and so on, alpha power n minus 1. Because, of course, my friend, forget about z power n is equal to 1, something like that. Suppose if a polynomial equation x power n minus 1 is given for you, then we can, because it is a nth degree polynomial, automatically contains n roots. Let the roots be 1 comma alpha square comma alpha cube, etc., alpha power n minus 1. So these are all what n roots. Here alpha is nothing but what? As I just mentioned now, e power I 2 pi by n. Got the point? So don't get any confusion. That these are all the several different notations. Okay. Why I have alpha? Because already what I mentioned by alpha k, I have given like this, where k equal to what? 0, 1, 2, 3 up to what? N minus 1. If alpha k equal to 0, that means alpha naught, I can get that as 1. If k is equal to 1, that is alpha 1, that I can get e power I 2 pi by n. If k is equal to 2, alpha k is I 2k pi. If k is equal to 2, alpha 2 equal to e power I 4 pi by n. Alpha, if k equal to 3, e power I 6 pi by n, etc., etc. If it is alpha, then it is what? Alpha square. Then it is what? Alpha cube, like this only. So these are all are what? Notations. So 1 comma alpha square, alpha cube, etc., etc. These are all are what? Alpha power n minus 1. These are all nth roots of unity. If these are the roots of nth, these are nth roots of unity, then if you observe all these things, then you will get an idea. Number one, the properties. Every line, every point, every concept is a bit. Sum of the roots is 0. That means 1 plus alpha square plus and so on plus alpha power n minus 1 equal to 0. That is what? They are in GP. They are in GP. Actually, my friends, whenever I am talking about the nth roots of the complex number, always all the properties of arithmetic progressions, geometrical progressions, they may take place, and we may utilize, or one can utilize all those properties very frequently for establishing other important results, especially in this particular area. So see, sum of the roots. So it is what? It is in GP, alpha power n minus 1 by alpha minus 1. But if alpha is root of the complex number, nth root of the complex number, then alpha power n is equal to 1. So it means what? 1 minus 1, that is 0. 0 by alpha minus 1, that is 0. That means if 1 comma 0 comma 1 comma alpha square, etc., etc., alpha power n minus 1 are nth roots of unity, then sum of the roots is 0. If it is sum of cube roots of unity is 0, sum of fourth roots of unity is 0. Similarly, sum of nth roots of unity is 0. And moreover, product of the nth roots is equal to, product of all these nth roots is equal to minus 1 whole power n minus 1. That is what? 1 into alpha square, alpha cube, and so on, alpha power n minus 1. You multiply that. That means alpha to the power of 1 plus 2 plus 3 and so on plus n minus 1. That is n into n minus 1 by 2. You simplify that. You will get answer as what? Minus 1 whole power n minus 1. Okay. Now what is product of cube roots of unity? That means alpha cube, omega cube. Okay. Omega square. That is omega cube is 1. 1 into minus 1 into y into minus a, fourth roots of unity. Again, minus 1 whole power 4 minus 1. That is what? Minus 1. Like that. Based upon the power, you can establish several results. Okay. So if product of sum of the nth roots of unity is 0, product of nth roots of unity minus 1 whole power n minus 1. This is important. Product of nth roots of unity minus 1 whole power n minus 1. So product of fifth roots of unity minus 1 whole power 5 minus 1. Product of 10 roots of unity minus 1 whole power 10 minus 1. That's why. So based upon that power, you may get sometimes 1 or minus 1. That is about product. Now, as I said in the previous video, all these roots what? They form a GP and they lie on a unit circle. Why unit circle? Because radius. Actually, for a general complex number, for nth roots of unity, for nth roots of the complex number, they lie on a circle of radius r power 1 by n. Here, the radius r power 1 by n means 1 power 1 by n, that is 1. So, they lie on the unit circle. Unit circle means a circle of radius 1 is called unit circle with the center as origin. And moreover, all these n roots are what? They are vertices of a regular polygon of n sides, which is inscribed in the above circle. All the properties are what? Just similar to the previous video that we have already discussed. Otherwise, you please check our lesson number 40. And moreover, the arguments of the complex numbers, they form an AP, and with the common difference what? 2 pi by n. That also I have shown in the diagram also. Okay, my friends? And moreover, 1 comma alpha square and up to the power of alpha power n minus 1 are the roots of z power n is equal to 1. Then where alpha is what? E power I 2 pi by n. That is nothing but what? Cos 2 pi by n plus I sin 2 pi by n. Then this is very, very important property. Sum of the roots, I can also write that as sigma k equal to 1 to n minus 1. This is what sum of the roots, that is equal to 0. And this kind of results are very, very important. Several times problems were repeated based on this. Even in our coming exercise problems also, you will solve this kind of problems so many. This is another form of what? By looking the cos 2k by n plus I sin 2k pi by n, immediately in your mind, you are getting an idea that, okay, they are nothing but nth roots of unity, and they are asking k equal to 0 to n minus 1 means there are sum of the nth roots of unity. Then immediately you can write answer as what? 0. If k is equal to 1 to n minus 1, that means actually sum of nth roots of unity means what? 1 plus alpha square and so on plus alpha power n minus 1 equal to 0. But I want alpha plus alpha square and so on plus alpha power n minus 1. What's that? That is minus 1. The same thing I have represented with k equal to 1 to n minus 1. Please try to understand the difference between k is equal to 0 to n minus 1, k equal to 1 to n minus 1. If k equal to 0, the first one is minus 1 it comes, and here it is k is equal to 1 to n minus 1. Therefore, I have sent that 1 to RHS side. Thereby, I got the result as what? Minus 1. Now, product of these roots. Just now I have mentioned it. Product of these roots. This is another way to represent minus 1 whole power n minus 1. That is what? From k equal to 0 to n minus 1. If it is k is equal to 1 to n minus 1, there is no problem. Because if you have multiplied something with 1, again you can get the same number. That's why there is no difference between k is equal to 0 to n minus 1 or k is equal to 1 to n minus 1 for product. So you can get the same result. That means here in properties 5, 6, 7, 8, these properties are what? Another form of the statements 1 and 2. Another form of the statements 1 and 2. And moreover, my friends, this is another important point here one should practice. That is z power n minus 1, it is a reciprocal equation. An equation is said to be reciprocal equation. If you replace z with 1 by z, you will get the same equation. Not only that, any algebraic equation is said to be the reciprocal equation. You replace in that equation x with 1 by x. If you get the same equation, then that kind of equations are called what? Reciprocal equations. Since z power n minus 1 is the reciprocal equation, so if z is a root, then 1 by z is also a root. Why I am very much specific on this particular one? Because if alpha is equal to cos theta plus I sin theta, if alpha is equal to cos 2k pi by n, 2 pi by n plus I sin 2 pi by n, 2 pi by n cos, if alpha is equal to cos 2 pi by n plus I sin 2 pi by n is a root, then 1 by alpha, that is cos 2 pi by n minus I sin 2 pi by n. This is also the root. This is also the root. That is the beauty of reciprocal equation. So whenever cos 4 pi by n plus I sin 4 pi by n is a root, then cos 4 pi by n minus I sin 4 pi by n is also a root. That means if you are finding, suppose, see for example, what are fourth roots of unity? Fourth roots of unity are what? 1 minus 1 I minus I. So if 1 is root, then automatically minus 1 is also root. If I is root, then automatically it's reciprocal, that is minus I is also root. That's why. If alpha is root, then 1 by alpha is also root. And moreover, sum of these roots, k equal to 0 to n minus 1, cos of 2k pi by n minus I sin 2k by n equal to 0. This is also equal to 0. Okay? And similarly, product, the same, minus 1 whole power n minus 1. There is no much difference between the above properties and properties number 10 and 11. Because they are what? Reciprocals. They are what? Reciprocals. And moreover, sigma k equal to 0 to n minus 1 cos 2k pi by n equal to 0. This is another important point, because if I have, this is if I have separated all the roots, the LHS is if I have separated all real part as well as imaginary part, and it is complex number 0, I can write it as 0 plus I0. If you equate the real parts only, then it is what? Sigma k equal to 0 to n minus 1 cos of 2k pi by n is equal to 0. If I have equated all imaginary part, that is sigma k equal to 0 to n minus 1 sin 2k pi by equal to 0. So that result number 12 can be extracted from what? Result number 10 only. And another important point is sigma k is equal to 0 to n minus 1 cos square 2k pi by n is equal to n by 2. Similarly, sigma k is equal to 0 to n minus 1 sin square 2k pi by n is equal to n by 2. How to get it? Cos square theta is equal to 1 minus cos 2 theta by 2, 1 plus cos 2 theta by 2. Similarly, sin square theta is equal to 1 minus cos 2 theta by 2. You establish that, you will get the same result. Clear? So there is no problem, because in the place of cos square k pi by n, I can write it as what? 1 plus cos 2k pi by n. Separate sigma. Separate sigma. Sigma 1 by n is equal to 1 by 2 equal to what? N by 2. Because k equal to 0 to n minus 1. There are n terms. There are n terms. So after simplification, you can get that as what? N by 2. Similarly, for sine square, k pi by n is also 1 by 2. So this is what simple trigonometric manipulations. But anyhow, these summations are all very, very important. Sometimes they are useful for solving some other technical problems. Again, my suggestion would be, you please practice all the results, and if necessary, you by heart these results, and they are the standard results also. Okay, my friends, hope you enjoyed this video. If you like this, you please share and subscribe my channel, and please don't forget to press the bell icon, and there you will get the continuous notifications and the coming lessons also. Okay, my